The beauty of the internet is I can cater to all your learning styles. So for those of you who are easily overwhelmed and you're not falling asleep when I teach, you'll want this version where I skip the ranting that's designed to keep the other people awake. You need to be able to balance the products and reactants of a given equation, relate the need to do this for conservation of mass and the consequences for our machinery and product creation if we don't do this properly. Explain which of the numbers in an equation demonstrates bonding and which is just a material count like weighing it or counting scoops of sugar. We show bonding by using the small numbers, so magnesium chloride is MgCl2. This is determined by the valence shells. You do not have an option to create MgCl3 any more than you could plug these two outlets together. The bonding is determined by the valence electrons, not by you. Once the small numbers are made, you have a package and you don't tamper with it. Very often, we will give you the formula. We may say copper tetrahydride, if such a thing existed. Or we'll say water and expect you to know it. Now, when we're counting the quantity of the material, not the way it's assembled, the amount of it, we use large numbers that you can consider to be scoops. For example, F2 is indicating a covalent bond between these two. They have welded themselves together, but 2K refers to two separate potassiums that have come into the room together, but there's no electrons being shared. There's no bond as each of these is going, you take it, no, you take it, no, you take it. This is 2-pair. Cl2 is written this way because there's a bond between these two chlorines, but there's no such bond this way, up and down. So we would call this 2-pair of chlorine molecules. If you think of blue jeans, it makes sense. Here is a pair of blue jeans. Here is another pair. So you would call this 2-pair of blue jeans, not one 4-legged blue jean. 2Cl2 can be read as 2 pairs of chlorine or 2 scoops of chlorine molecules. Cl4 cannot exist. And if it existed as pants, that would be something like this, a set of pants with 4 legs on it. So the bonding is internal here, not spanning these. So let's look at a simple example. Table salt. Sodium and chlorine gas make sodium chloride. Chlorine gas is always in a pair. All the halogens are. You will be told that on any test. When we look at the Lewis dots, this is what's going on. Sodium, covalent pair of chlorines, and it bonds to this. But that looks good, except one of the chlorines has gone missing. And she's kind of sad because she didn't find a partner. So if we bring in a second sodium, we can marry her off as well, and we're able to form 2 sodium chloride molecules. But that required doubling the 1. Why wouldn't we put a little 2 instead? Because that would indicate that they have somehow shared or transferred electrons between them, and metals just don't do that. You could read this as 2 scoops of sodium and 1 pair of chlorine makes 2 scoops of salt. Let's look at another example. If I said to you on a test, iron 3 and oxygen react to form iron oxide. The iron 3, I am telling you, is +3. That's what that means. Oxygen is always O2. And iron oxide, you have to figure out. Well, if iron is +3 and oxygen is -2, you would have to draw this for the Lewis dot. Or use the crossover method and leap to the answer. You've assembled iron oxide in the only way it can assemble, given that number, and the -2 that's on oxygen. You can't tamper with the little numbers now. You have to adjust the scoops of each material to get them to balance. So if we move on to iron, oxygen, to iron oxide, we need to figure out what scoops would be needed to balance this out. So let's look at it pictorially. We have an iron atom, a pair of welded together oxygens, and this molecule here that looks like a fidget spinner. These are the clusters. You can't tamper with them now. You're not free to just knock off one of these irons and oxygens so it agrees with the parts you have. We have to start boosting scoops of these. The obvious problem right off the get-go, 2 oxygens, 3 oxygens. Yes, there's 1 iron and 2 iron, but I'm going to encourage you when you see an odd even split, tackle that first. The only time the numbers 2 and 3 land on the same number is the multiple is 6. 3 pair and 2 triples. So that would now fix the oxygen count. The trouble is, iron is even worse than before. 2 pair of irons and a single iron. So we need 4 irons. So the fix is quite simple. Now we've balanced it. And that's what it looks like. Iron combined with oxygen, one of iron oxide's forms is Fe2O3. It's a brown colored rust. And you've probably seen old metal turn into like brown dust. You often see it coming off the grinding wheels in shop class. You grind metal, there's no silver sparkles on the floor. There's like a brown or a red or a black dust because it caught fire in the air. Rusting is just a very slow form of fire. Iron oxide could come in another form. Iron 2 oxide, which looks black, is dead easy to make. Fe+2, O-2, one of each will work out just fine. And then to fix it, you had 2 oxygens go in, so you better have 2 coming out, which requires 2 irons. Again, you don't put a little Fe2 because that implies the iron bonded to itself, and it wasn't. It was all alone. Metals do not bond with other metals. Now here's some really important ones for home. This is the natural gas that you use in your hot water tank in your furnace. When we take a quick look at it, we start off with carbons. There's 1 going in, 1 on the other side. So the carbons are fine. We switch our attention to the hydrogens. 2 are here, 4 are there. You may not alter this 2 to H4O. Such a thing can't exist. You do this instead. You double it up. You have enough hydrogens to assemble 2 waters. Now the last atom to look at is oxygen. 2 oxygens here, 4 on the other side. So we have to deal with the fact that there are 4 oxygens here and 2 here. And the fix is easy. Double up the scoops. Okay? What about hydrogen? Start off with letter at a time and see what you got. 2 oxygens, 1 oxygen. So we should be able to double that, fix the oxygens. Now we've got 2 pair of hydrogens and only 1 pair went in. So we fix it by doubling up that. In summary, if we look at the 2 equations, hydrogen burns to water vapor. Methane burns to water vapor and hopefully CO2, but it could make CO and it could make C. That would happen if we didn't provide enough oxygen, which you saw me demonstrate with the Bunsen burner. If you have lots of oxygen, the methane flame will be blue, meaning it's well oxygenated. If you see yellow, there is definitely carbon monoxide. Hydrogen